Did you know that our Milky Way galaxy harbors a supermassive black hole at its center? This behemoth isn't just a cosmic vacuum cleaner. It plays a vital role in shaping the galaxy's structure and evolution. Get ready to have your mind blown as we uncover the secrets of black holes and their surprising influence on our own galactic home. Black holes are some of the most mysterious and fascinating objects in the universe. At their core, they are regions in space where gravity becomes so incredibly strong that nothing, not even light, can escape their pull. This is why they're called black holes. They emit no light, making them invisible against the backdrop of space. But how do they form? Most black holes are created when massive stars, those much larger than our sun, reach the end of their lives. When such a star exhausts its fuel, it can no longer support its own weight and collapses under its own gravity. This collapse results in a supernova explosion, and what's left behind can compress into a tiny but incredibly dense point called a singularity. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. Together, these features make black holes one of the most extreme phenomena in the universe. Now, let's bring our attention closer to home, to our very own Milky Way galaxy. Did you know there's a supermassive black hole right at the center of it? It's called Sagittarius A*, and it has a mass of about 4 million times that of our Sun. While we can't see this black hole directly, astronomers have studied the way stars near the galactic center behave. They move at incredible speeds in tight, elliptical orbits, as if being tugged by a massive but invisible force. This gave scientists strong evidence that something extremely massive and compact like a black hole must be sitting there. But Sagittarius A* isn't just sitting idly. It plays a big role in the structure and evolution of our galaxy. It helps shape the movement of stars and gas around it, and might have influenced how the Milky Way formed in the first place. Believe it or not, black holes don't just destroy, they can also help create. One of the most surprising things about black holes is their role in star formation. Their intense gravity can cause nearby clouds of gas and dust to compress, triggering the birth of new stars. This happens especially when black holes feed on surrounding matter, a process known as accretion. As gas and dust fall toward the black hole, they spin into a swirling disk around it. This disk becomes incredibly hot and emits powerful radiation. This energy can push and shape nearby clouds, encouraging them to collapse and form stars. In fact, some galaxies go through episodes of starbursts. Rapid, intense star formation and central black holes are often involved. So, in a cosmic twist, these monstrous objects can be both destroyers and creators, shaping the life cycle of stars in the galaxy. Now imagine two black holes caught in a cosmic dance. They slowly spiral toward each other, getting closer and closer over millions of years. Eventually, they collide and merge into a single, larger black hole. When this happens, it releases an enormous amount of energy in the form of gravitational waves, ripples in the very fabric of space and time. For a long time, these waves were just a theory proposed by Albert Einstein. But in 2015, scientists at LIGO Laser Interferometer Gravitational Wave Observatory made history by detecting them for the first time. Since then, more gravitational waves have been recorded, many from black hole mergers. These discoveries have opened up an entirely new way to observe the universe through gravity itself. It's like listening to the universe's heartbeat and learning secrets that light alone could never reveal. Even with all we've learned, black holes remain one of the greatest mysteries in the universe. But the future of black hole research looks incredibly exciting. Projects like the Event Horizon Telescope are already making waves. In 2019, the EHT gave us the first ever image of a black hole's event horizon in galaxy M87. Now, scientists are turning their attention to Sagittarius A*, aiming to capture an image of our own galactic center's black hole. Looking even further ahead, missions like LISA Laser Interferometer Space Antenna will launch into space to detect gravitational waves from black holes across the universe. These space-based observatories will be able to catch signals that ground-based detectors might miss. All of this research matters because understanding black holes helps us answer some of the biggest questions about the universe: how galaxies form, how matter behaves under extreme conditions, and even what might happen to space and time in the far future. The more we learn, the closer we get to unlocking the secrets of the cosmos.